Okay, so today we're talking about sound waves. Sound waves, if you recall, when I was talking about the properties of waves, are longitudinal. And they travel through different medium or media. So they will travel through gas, liquid, and solids. And if you recall, longitudinal waves travel parallel in the motion to the motion of the particles. So longitudinal waves travels parallel to the motion of the particles they are traveling through. Whew. All right. Now, sound waves how do I want to say this? Waves travel at different speeds through different media. So, sound travels faster in solids than liquids. And it travels faster in liquids than in gas. So this means if I made a sound in the air and the sound wave traveled and it hit like some body of water, it would speed up when it hit that water. And when the sound wave traveled through that water and hit the ground, say underneath that water, it would then speed up even more as it was traveling through the solid ground. I will show you some examples of sound traveling later this afternoon. I'll post those videos. So here is my tuning fork. You may have seen Miss Kirsten has one of these. They are a metal two-pronged object with a handle. And when you bang it against something, these two prongs then vibrate. And the sound travels out from them. And we kind of draw sound looking like a ripple, but in fact it looks more like this. So it is our wave pattern. And sometimes that wave pattern can compress and expand as it is passing through different media. So this would be a compression. And this area here would be an expansion. In a compression, the wavelength shortens due to the density. And in expansion, the wavelength lengthens. What kind of things are going to cause this expansion and compression? Well, when it is transitioning through different material as the density of the media changes, and temperature. Can affect sound. So the temperature of the medium higher temperature sound moves faster. When the temperature is colder, the sound moves slower. And that intuitively might make sense because we talked about if the temperature, for example, of the air is cold, there is not a lot of kinetic energy in the molecules. So the molecules themselves are not moving. And as sound comes, so low kinetic energy, low temperature, slower sound, because these molecules are not passing the sound on to the next one. Whereas if we have higher temperature, these molecules are moving around faster, they have higher kinetic energy, higher kinetic energy, and faster sound. Now, how fast does sound travel? Well, you all know from thunderstorms or from watching fireworks displays that sound travels more slowly than light. And when we were talking about electromagnetic waves, we talked about the speed of light traveling very fast. I don't have it written down right in front of me, but the speed of sound is 340 meters per second. This is why you see lightning before you hear thunder. And for an airplane or a vehicle to break the sound barrier and cause a sonic boom, it has to be traveling 340 meters per second. We talk about sound. We use a couple of words to describe it. When we're talking about how loud something is, we are talking about the intensity of the sound. The sound's intensity is how much energy is being carried. The amplitude of the wave is equal to its intensity. So when I drew the first wave pattern way back when, and we talked about the height or the depth of the waves, of the crest or the troughs, this was the amplitude. And it tells you how much energy the wave is carrying. So the amplitude of the wave is equal to the intensity. The larger the amplitude, the higher the intensity. Is the louder the sound. We measure sound using a scale, which you also might have heard of before. The scale is called the decibel scale. So sound is measured in decibels. And the abbreviation is lowercase d, uppercase b, decibels. This measures the intensity of the sound. So for every increase of 10 decibels, so if I start at 10 decibels and I go up to 20 decibels, I have increased my energy in my wave 100 times. So for every increase of 10 decibels on the scale, you are increasing the amount of energy 100 times. The other term we use when we're talking about sound is called pitch. Pitch is how we perceive frequency. Frequency is how often that wave is repeating. So, an increase in pitch equals an increase in frequency. Running out of room. For humans, our hearing range is from 20 hertz to 20 kilohertz, or 20,000 hertz. Below 20 hertz, we call that infrasound. And something that would make infrasound that we cannot hear are deep earthquakes. Above 20 kilohertz is called ultrasound. And this is what bats use for their echolocation. That is sound in a nutshell. I will be posting some experiments, some demonstrations about sound waves, and hopefully you will enjoy them. Thanks.